Now that I've proven that circle theorems are not as difficult as they seemed, stay with me as we explore a few more circle theorems together. Welcome to part 2 of our circle theorem series. In the classroom, it's not hard to see that some students find it challenging to distinguish between their theorems and when each of them should be applied. This can lead to a lot of time being spent trying to figure out which theorem to use. This now takes away from the overall problem-solving process. I've taken the time to break these theorems into parts, giving you a clearer understanding and also change your approach to this topic. Now, let's recap. So last lesson, we looked at 3 theorems. If you haven't watched that lesson, I would suggest that you go and do that now before accessing this one. The reason for that is some of the theorems that we've looked at in the last lesson are crucial to the ones that we're going to be looking at today, particularly when it comes to accessing questions that rely on those previous theorems. So the first one we looked at was angles in a semicircle at 90 degrees. Second one we looked at was angle at the center is twice the angle at the circumference. And the third one we looked at was radius and a tangent meet at 90 degrees. So today we're going to carry on. So we're going to look at rule number 4. So rule 4 says the opposite angles in a cyclic quadrilateral at 180 degrees. Key point here, a cyclic quadrilateral is a 4-sided shape. Important part I've highlighted here is that every single corner of this quadrilateral has to touch the circle for this theorem to be applied. So when that happens, the opposite pairs of angles will always add to 180 degrees. Now, I'm just highlighting this a little bit more because lots of students tend to believe that once they have a quadrilateral in a circle, then the cyclic quadrilateral principle applies. No, all the edges of the quadrilateral has to touch the circumference of the circle for that rule to be applied. So let's look at it diagrammatically. So here I've got a circle and I've got a cyclic quadrilateral. You notice here that all the edges of the circle are touching onto one corner of the quadrilateral. So therefore, the angle C and A will be equal to 180 degrees because they are opposite facing each other, and also B and D would also add to 180 degrees. So I've put those equations at the bottom there for you to make that relationship among the angles there. Also, I can't stress enough, every lesson I've talked about orientation as it relates to the circle. So therefore, these are different orientations that also applies to this theorem. And of course, by now you know that once we've looked at a theorem, we are going to practice some questions. So let's go ahead and do our first example. So example number 1 asks us here to find the value of the angle marked X. And also we are asked to give reasons for our answer. And remember, in previous lessons I've said, even if a question doesn't ask us to give a reason for our answer, we always do that so that the hidden marks that may be there on the mark scheme, we can score those marks anyway. And also it's a really good way to help you to remind yourself of those theorems. So here, remember, we are thinking. I look on my diagram and I want to find the value of X. I then ask myself some questions. What key information could I use first of all to at least know one angle within the quadrilateral? And so my first reason is that angles on a straight line add to 180 degrees. So therefore, I can find this missing angle here, which I'm just going to call Y. So then I'm going to write my equation. Remember, for your first method mark, your examiner needs to see your line of thinking. So the best way to do that is to write an equation that links the angle within the quadrilateral and the one that's on the outside. So I'm just going to go ahead and do that. Y plus 102 degrees is equal to 180 degrees. And remember, even though this is a simple one, you can also just use your calculator quickly and put 180, take away 102. Very simple one, so you didn't have to do that. But remember, I can't stress enough that in an exam situation, you will be under pressure. So it's a paper 2, use your calculator. So it's 180 minus 102 degrees, and the answer for that is 78 degrees. I'll go ahead and I'm going to put that on my diagram so I can see my gaps closing in. So 78 degrees. I rely then on my theorem that I've just learned for the second part of my question. And let's see if you're able to think that through. Because I just told you that the opposite angles in a cyclic quadrilateral also adds to 180 degrees. So I know then that 78 add x will also be 180 degrees. I hope that you figured this out. So x plus 78 degrees is equal to 180 degrees. I can see then it's the same relationship that I've just developed at the top of my equation. So here, if x plus 78 is 180 degrees, and y plus 102 degrees is equal to 180 degrees, then I can deduce that x then is also going to be 102 degrees. So x will be equal to 180 take away 78 degrees. So therefore x is 102 degrees. Okay, we can see that the angle here between the chord is 102 degrees and also the one that is in the quadrilateral. So therefore, we have found our answer. X is 102 degrees. We use two concepts here. Angles on a straight line add to 180 gets us the angle inside of the quadrilateral. That was our link to finding the angle that we were asked to do. And our second reason was the opposite angle in a cyclic quadrilateral also adds to 180 degrees. Okay, so now we're just going to move on to a second example on this theorem. So example number 2. In this question, we're asked to find the value of the angle marked y and also give reason for our answer. So I go on to my thinking process. What can I do? I recognize I've got a cyclic quadrilateral. I check all ends of my quadrilateral makes a connection with the circle. So yes, this is a quadrilateral, cyclic quadrilateral. So I know the opposite angle here plus y will be equal to 180 degrees. The question then becomes, how do I find at least the one at the top that will help me to find y? So this is what I meant at the beginning when I said a theorem we have done in the previous lesson could help us to find the angle here. So I've also mentioned before that sometimes your chord is not visible. But if I put my chord in here for myself, I can see that 144 degrees here is the angle at the center of this circle. So my first reason is that angles at the center is twice the angle at the circumference, which means that if I call the missing angle here x, then x would be equal to 144 degrees divided by 2. And that gets me the matching angle to y. So let's go. 144, if I do 14 first of all divided by 2, that's equal to 7. And then 4 divided by 2, so is 144 divided by 2 then gets me 72 degrees. I then put that on my diagram so that I can close my gaps. here. So I have enough information now to find the angle I was asked to do. And that reason is the opposite angle in a cyclic quadrilateral add to 180 degrees. So I know then that y plus 72 degrees would be equal to 180 degrees. So all I need to do now is just to do 180 degrees, take away 72. And remember, if you're not that skilled at your mental math, all you need to do is to just put that into your calculator. So I'm just going to do that. Easy one to calculate from the brain, however. So that is equal to 108 degrees. So I have now found my answer. You can see that as you deal with the theorems one at a time and you practice it, it's really not that complex at all. Now the hardest part of circle theorems is when you're asked to prove these theorems, and we're going to get into that in our third and final lesson of this series. So stay with me, and also make sure that you look around, make sure you've pressed your notification bell, so that whatever you're doing, once you hear that ping comes in, it could be your third lesson, which is very, very critical for you to score on those top grades. All right, so we've done our first theorem in part 2 of our series. So we're going to move on to our second theorem, which is rule number 5. So rule number 5 says that 2 radii creates an isosceles triangle. Now remember, in our previous lesson we talked about the radius of a circle. So the plural of that is radii. So diagrammatically this is what it looks like. So if I create a triangle from 2 radii in the circle, the triangle is always going to be an isosceles triangle. And I've put the colors here so you see that the angles at the base of the triangle is what is going to be equal. And also remember, cannot stress enough about the orientation. And remember, I spoke to you in last lesson that sometimes you have to turn your paper so that you can visualize what the question is asking you to do. Okay, so with that being said, we're going to look at our first example around this particular theorem. So example number 1 asks us to find the value of the shaded angle below and give reasons for your answer. So as I look here for my solution, I'm thinking I can see here that I've got 2 radii. I also know then that the triangle in question is an isosceles triangle, which means that the shaded angle and the other angle at the base will be the same. So I'm just going to call one angle x, so the other one also is going to be x. Therefore, I can write an equation that links the angles in the triangle in terms of x. So then x add 118 degrees will be equal to 180 degrees. Okay, using my algebraic skills, which I'm sure you've got, because at the beginning we looked at some simplification of algebraic term in previous lessons we've done, even if it was in another topic. But by now your algebraic skills should be growing. So we know that x add x is equal to 2x. So we've got 2x add 118 degrees is equal to 180. So we're going to do our inverse operation. So what I need to do here is to subtract 118 degrees from both sides. So I put that in my calculator to make sure I'm correct. So take away 118, and that gives me, so 2x then will be equal to 62 degrees. So that means to find the value of x, I just need to divide both sides by 2. So x then will be equal to 62 divided by 2. I like to break my things apart, so I say 6 divided by 2 is 3, and 2 divided by 2 is 1. So I know that one angle, my shaded angle then, is equal to 31 degrees. And also, remember, you can prove your answer, because if I put on my diagram here 31 degrees and 31 degrees, and then I add all the angles in the triangles, I recognize the answer will be 180, and that's how I know I'm correct. Well done for making it this far in the lesson. But question is, sometimes we watch our videos and we engage and we love the content, but guess what? We forget to subscribe. So have you subscribed yet? Have you shared and told your friend to subscribe and asked them to share along? If you haven't done so, just make a pause, hit that subscription bell, and make sure that you share along as well. Okay, with that being said, let's look at another example around this particular theorem. So, example number 2, we're asked here to find the value of the shaded angle below and give reasons for our answer. Now, we can see here that the shaded angle in question is a reflex angle, and that angle is on the outside of my triangle. But with my knowledge of two radii creating an isosceles triangle, I can reason that if I know one of the base angles, then it's simple reason that I also know the other one in the isosceles triangle. So reason number 1, my theorem, two radii creates an isosceles triangle. So I'm just going to write that one in on the diagram to close my gaps. So that means I will now need to find this angle here that will complete the circle. So I'm going to now draw for rule number 2 that I could use here. So I know the angles in a triangle are to 180 degrees. I'm just going to call this angle here y. So I know that y add 57 degrees should be equal to 180 degrees. So we're just going to do that. 57 add 57, that gives us 114 degrees. So y is equal to 180 degrees, take away 114 degrees. Put that back into my calculator. Y is equal to 66 degrees. And remember, always put your answer on your diagram. It is very important to close those gaps. So I'm just going to put my 66 degrees here. Now I notice that I've got angles around a point. So I'm just going to use that reason here. Angles around a point add to 360 degrees. So the angle in question, let's just call that x since there was no name given to it. So we know that x is going to be equal to 360 degrees, which is the total around our circle, take away 66 degrees. So again, I'll just put that quickly into my calculator. So take away 66. So x then is 294 degrees. Now, I can use my knowledge of estimating angles to say, okay, this is reflex, so clearly my angle is going to be somewhere above 180 degrees. So that's also a way I can know if the angle I have been given, or rather the angle I've worked out, seemingly is correct. And yes, the angle is 294 degrees. So yes, you have now used your fifth theorem, and you have successfully answered 2 questions around that theorem. Now remember, as you go along and you access exam style questions, all these theorems will come into focus. You will not be doing one theorem at a time, so we're looking out for what possible theorems could I use to close the gaps in my question. Okay, now we are going to move to the final rule in this particular lesson. So we're going to look at rule number 6, which is the equality of tangents from a point. So we looked previously at the part of the circle and we talked about the tangent is that straight line just touching one point on the outside of the circumference. So the 2 tangents drawn from the outside point always touch the circle at the same distance. This creates a reflective situation, and also 2 congruent triangles will be created as well. So visualizing that, I've got a point here, and from that point I've drawn 2 tangents touching the outside of either part of the circumference. Now if I put my radii in, I can see here that a perpendicular effect has taken place, which simply means that the angles formed will be, so radius and tangent also is a theorem we've looked at, they will always meet at 90 degrees. Now, if I just draw a line in here, you can now see the reflective property, which means that the angle here is a reflection of the one on the other side, so those two are equal, and also the ones here at the base of these triangles are also reflections of each other. So I've now put that in and labeled them so you can see. So for example, if this angle here is A, the other angle will also be A, and that's because they are equal. And here, this angle is B, the other angle will also be B in general. Okay, so we're going to put that theorem into practice. So in this question, we're asked to find the value of the angle marked X, and we know we have to give a reason for our answer. So if we look here, we remember straight away that the angles from the radius and the tangent will meet at 90 degrees. So rule number 1, a tangent is perpendicular to a radius. So I'm just going to go ahead and put 90 degrees here and also 90 degrees there. Once I've done that, I remember my rule that tells me that the angles in a quadrilateral will always add to 360 degrees. So now I know 3 angles within this quadrilateral. Very important to note here that this is not a cyclic quadrilateral. Why do you suppose that's so? I hope that you've said all 4 vertices of the quadrilateral did not touch the circumference. If you've said that, I'm absolutely proud of you. Okay, so I can either use 360 degrees here, or I can make it simpler by recognizing that I've got 2 90 degrees angles, this one here and the other one here, which means that those 2 angles would add up to 180 degrees. So to make it simpler then, it means that X and 133 will also need to add to 180. So I'm going to take that route, simpler route. So X plus 133 degrees should be equal to 180 degrees. So now I just need to do subtracting 133 from both sides of my equation. And I'm just going to put that in my calculator. So 180 take away 133 degrees is equal to 47 degrees. So therefore, I found my answer, X. Again, I cannot stress enough about listening to the questions I ask myself and the logical sequencing that I've made for myself. And once you've applied that principle, it is so much easier to smoothly arrive at your answer and also ensure that you are accurate. Okay, so we're going to look at a second example. So in this example, we're asked to find the value of the angle marked Y and also give a reason for our answer. Good. So again, we know that the radius and the tangent meet at 90 degrees. So we go ahead and we put our 90 degrees in. We notice here that what we're asked to find is not the angle within the quadrilateral, but rather the reflex angle on the outside. But we have enough information to do that because we know that the angles in the quadrilateral will add to 360 degrees. And like we've done in the question before, we can go the 180 route because we know that these 2 angles add to 180, which means that 66 plus, let's call this one X, will also add to 180. So let's just go that route. So X plus 66 degrees should be equal to 180 degrees. We go ahead and we do 180, take away 66, and that gets us 114. Just going to write that down. 66. So X is 114 degrees. But I was not asked to find X. Rather, I had to find that in order to find the reflex angle. So I'm just going to go ahead now and I'm going to call y plus 114 degrees should be equal to 360 degrees. So we know we have to do the inverse of our operation here. So I'm going to do 360 degrees, take away 114, and the answer for y then is 246 degrees. And yes, just like that, you have found your answer. I know you're saying, oh, it's so much simpler than I thought. Yes, it's just that little step-by-step approach makes it so much easier. I'm happy that you've gotten this far in the video. So what we're going to focus on is what we always do, our key takeaways. And I'm so excited to bring you the last lesson that's coming up in this series, because lots of little goodies there. Those are where we're going to now look at our proof questions with our 4 and our 5 markers. Those ones on the back of the paper usually pose a challenge. But once I show you how to do this, you've got some more marks that you're now going to put in the bag. And guess what? The grade 7, 8, and 9 is loading. So make sure that you look out for that. But let's just wrap this lesson up. So theorems we've looked at in this particular lesson. We've looked at the opposite angles in a cyclic quadrilateral at 180 degrees. And remember, key point here, for the quadrilateral to be considered cyclic, the corners, all 4 corners, have to touch the edge of the circle, the circumference. Okay, next one we looked at was 2 radii creates an isosceles triangle, and we know that the base angles in an isosceles triangle are always equal. And finally, we looked at the equality of tangents from a point, and we said that that creates a reflective effect, and also the angles within the quadrilateral created will always add to 360 degrees, and we will have 2 right angles because the radius and the tangent meets at 90 degrees. I'm so happy that you have stayed with me. Means that you are absolutely interested in your education. And what can we ask for as educators? Once you're interested, remember, it doesn't matter how long it takes for you to grasp a concept. Continuous pursuit of knowledge will help you to be victorious in the end. Never give up. Always ask for help if you need it. Never be afraid to ask for help. So I'm looking forward to see you in the conclusion of this series. Lots of goodies, I say, is coming out for you. And so remember, I cannot stress it enough. I am so thankful that you are a part of my community. And you have helped me so far to reach other people because the subscribers are growing. I'm so proud to say that at this point, we have over 300 subscribers. So let's continue to build. Remember, share, hit the notification bell, like the video, and also feel free to comment topics that you want me to do. Until next time, have a lovely day.